Welcome back to day 34 of the Edulexis Python course. Previously, we looked at handling built-in errors like value error or type error. Today, we're taking it a step further, creating your own custom exceptions and forcing errors to happen using the raise keyword. This is incredibly useful when your code runs perfectly fine technically, but violates a specific business or application rule. Let's look at this simple example of a cash withdrawal function. If you have $50 and try to take out $200, Python executes the math flawlessly and outputs -100 and 50. From a mathematical standpoint, everything is fine. But for a real bank account, this is a massive error. Python doesn't know your business rules natively, so we have to enforce them manually to stop the program immediately when a business rule is broken. We use the raise keyword. Look at the updated function on your screen. If the demanded amount is greater than the balance, we forcefully raise a value error with a descriptive message. Running this code stops execution immediately and prints our message directly to the console. While a standard value error works, it isn't specific enough for complex apps. To make our code cleaner, we can create our own custom errors. All standard errors in Python inherit from a main parent class named exception. By making our new classes inherit from it, they instantly get all the built-in properties of a standard Python error. To create a custom exception, you only need 2 lines of code. We define a brand new class, call it low balance error, and put exception inside parentheses to inherit its functionality. We use the parse keyword for the body. Now, Python treats this class as an official, recognizable error type. Let's substitute our brand new error into our original function. Instead of raising a generic value error, we now raise low balance error. Watch what happens when we execute it. Now, the console traceback no longer prints a generic error, it explicitly states low balance error. This makes logging much more informative. Once you have a custom exception, you can catch it cleanly using a regular try except block. By writing except low balance error as we can gracefully intercept this specific issue without catching unrelated problems. Your program won't crash, it will handle the event safely and keep running. You can scale this up by creating multiple custom errors for different scenarios. For example, let's create an action blocked error to handle suspicious activities or frozen accounts. Having independent exceptions for separate situations allows you to build highly responsive, production-ready applications. With multiple errors defined, you can stack your except blocks to handle each problem uniquely. If a low balance error occurs, you can ask the user to deposit money. If an action blocked error happens, you can trigger a security alert. This keeps your error handling architecture well organized and modular. Since custom exceptions are standard Python classes, they aren't limited to just plain text messages. You can add attributes to them to pass actual data along with the error. This lets the part of your program handling the error know exactly what went wrong without needing to parse text strings. Let's add a constructor method to our class. Inside __init__, we accept the current balance and the needed amount, saving them as properties. We then use super.__init__ to send a basic message up to Python. Now, our error object acts as a smart data container. When you catch this updated error, you can read those custom fields directly using dot notation. Typing a .current gives you the exact balance state at the moment the exception occurred. This eliminates complex parsing and gives you clean, structured data right inside your error recovery code. When writing custom exceptions, keep 2 simple guidelines in mind. First, always end your class name with the word error so it's instantly recognizable. Second, keep them specific. Don't make one generic class to handle every single problem in your application. Use separate, descriptive classes. Using these techniques helps keep your code organized, easy to test, and highly reliable. Instead of tracking down unexpected bugs, you define the exact boundary lines for your application logic and let Python enforce them automatically when things go off track. To summarize, inherit your custom classes from exception. Use raise to trigger them, and add properties to store data. Try building a few custom errors in your projects today. Don't forget to like this video, subscribe to Edulexis, and click the bell icon. See you in day 35.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.